Hello, welcome to the stream to where I fix stuff. This is an RCA R28P. This is like 31 or 32, maybe 33, something like that. It's in pretty bad shape. Some of the veneer is missing here. Some of the actual wood behind the veneer is missing there. It's all coming apart here. Veneer is missing there. Someone's had a sticker there. See, it got wet here. This is all falling off on the side there, so not in the best of shape. The top's got some stickers and tape on it. These knobs, I don't know, this is the tuning obviously, I'm not sure you can see it's got a black tuning dial, I'm not sure if you can really see it moving in there or not. This knob, like, goes up and down. So I don't know what's up with that. This knob doesn't seem to do a whole lot. This is the power volume, I'm assuming, either or power tone, something like that. Sometimes they do that on these radios. Glow cloth doesn't look too bad. It's got there's a little short there, tiny little gap. But other than that, it doesn't look too bad at all. But the issue, flip it around, is all the tubes are missing. It does have one tube shield though. Usually these go missing before the tubes do. Now no insulation on this wire at all, really. Same thing with this one. Power cord doesn't look like it's got any bare spots, but it's definitely not in the best of shape. I don't even know where this is going actually. Got it wired in. I don't know. That's gonna have to get figured out. And my favorite part, this is gonna have to take some closer inspection, but it looks like this is adhesive tape underneath the speaker. So did they just glue the speaker down with a roll of tape? Actually, this is loose even. So yeah, this is gonna be a fun one. I'm not gonna put the tubes in and power this up in this state. This is just gonna short out and fry something. So let me get this out of the cabinet, take a look at what exactly we have, and if nothing seems too terrible, actually I can see a mouse nest down there. It's like a mouse nest down in there. So hopefully the mice didn't eat the transformers. So yeah, let me take this out, just see what we've got here. What this is, okay, this isn't the power cord, and this is, it must be the antenna, I guess? Okay, so yeah, this is the antenna, so never mind. Alright, so that's the antenna going up there, the power cord goes in down there, that's probably fine. Okay, so yeah, let me take this out, see what we've got, and see what we can make with this thing. Well, there he is, or what's left of him anyway. Our friend the mouse. You see his tail there, and looks like some of his ribs there. Sure if we can find any other parts. Not really looking that way. I can see anyway. So I have to clean him out. I don't think he'll mind. So it doesn't look like our friend the mouse got into the power transformer, but he did do some chewing on one of the IF transformers, which you see in front of you. I unwound all of that wire from both of those coils, and I do have continuity across both those coils now. Most of the coil is still there, so hopefully, the change in inductance will be small enough that we can still adjust it with the tuning capacitors. You can see up here is where that coil used to be mounted. Here's one side of the frame, then it mounts across the other side, and then it's got those old style, leaf capacitors. You can really see it there, but like, get some kind of pointing device here. Hold on. You can see this right here is the top of the leaf, and then there's a screw down here, and then turning that screw raises and lowers the leaf to adjust the capacitance. So hopefully we'll be able to adjust those for the loss of inductance in those coils, which Doesn't think it should be a whole lot, but we'll see. I have to pull a schematic on this, but I did check the coils in these cans. Seem to be okay. Just did some quick continuity checks, and I got, without knowing what's supposed to be connected to what, I did get continuity like from at least one terminal to one other terminal. So, there could be other connections that are supposed to be there that I'm not checking because I don't have the schematic. But for now, we're just going to go with that. I'll reconnect the coil back in here. So I got some dangling wires in here. This is what used to be connected to right there, and then that was what was chewed off at the coil. I'm still going to check the power transformer, just check for continuity, for the phone winding and the B plus winding, and make sure that, it hasn't gone open inside without the mouse. Because, whenever you find a radio with all the tubes pulled out of it, that means that that means that someone put it away and wasn't planning to use it again. So either, they got a new radio and just pulled the tubes out. That's usually not the case. Usually if someone puts a radio away because they got a new one, they leave the tubes in it because the new radio wouldn't use the same tubes, most likely. At least not something from this era. These tubes were basically obsolete by the mid to late 30s. Or they put it away because something was damaged in it and they saved the tubes for using something else. And when that happens, you kind of wonder what broke and made them put it away, that it wasn't going to ever work again. So I doubt that the mouse would have lived in here when the radio was in use and caused this damage. Usually, the mice only move in, most of the radio's been away for a while. And, actually, that could explain the damage to our cabinet too, because that corner right there is where the mouse nest would have been. So, maybe mouse pee is what got the cabinet wet and loosened that veneer. There's also something interesting too that I noticed. Let me back over here. Sure if you can see, but there's our mouse in it, but there's also some eggs too. Not sure why there'd be all these eggs in the mouse nest. It's kind of interesting. Don't know if mice eat eggs or even what kind of eggs those are. They're pretty small. Could be bird eggs, but I don't know. It's kind of interesting. Anyway, let me put this coil back in there, and probably going to replace at least the main electrolytics before powering this up. Some of these capacitors look pretty sad here. You can see the mouse was probably chewing on that one. Got a couple of mouthfuls of tar with that one. Anyway. Alright, so I soldered that the transformer back in. I got a new power cord installed, got all the tubes populated, replaced that wire there for the grid cap on a tube in the back there. So let's just plug this in and turn it on and see what happens. I did check continuity through the power transformer and that checked out okay. Let's see if we can plug this in here. It should be off. Yes. Nothing exploded yet. I should have run the knobs here, see if this will work. That doesn't sound too good. Power transformer sounds awfully loud. I did see the tube start lighting up, but I don't know about that. Let me pull the rectifier tube and see if that makes any difference. I don't think it really would have gotten hot enough to. That thing's still cold. The socket's in pretty bad shape too. See if it makes the same sound. Yeah, something doesn't seem quite right there. Wonder there's a capacitor. Oh, that capacitor shouldn't matter because that's off the. I was going to say there's a capacitor here on the base of the rectifier tube, but I think that's on the other side. I can clip that out and see if that makes any difference. Unless, something in that socket is shorting out or something. Let's see if we can just clip this guy here. Doesn't really feel warm though in any way. I don't know. Unless it's shorted internally or something. Let's clip that out, see what happens. Oh, it's still doing that. Let me check the voltage coming off of there. We can get this set up here. Stupid meter keeps turning itself off. Okay, this is not in the frame. Let's get it in the frame, maybe. Okay, we want, yes, AC volts. So let's see. These two should be the 5-volt filament. Oh, that doesn't seem right. These two should be probably around 400 or 500 B plus. Maybe I have this backwards. Let's check, well, how do I do this? We can check resistance here. So resistance across these two is, oh, that's stupid. Not making good connection here. 0.6 ohms. Resistance across these two. So that should be the higher voltage. That has the higher resistance, Higher resistance means more turns in the transformer, generally speaking. Or it could be a different wire gauge, but in this case, we're expecting one very short winding and one very long winding. So we'll go with the higher resistance winding as the very long winding, which will produce the high voltage. Not high voltage, but higher voltage, B plus voltage. So that was only measuring like 6 volts on or something. That doesn't seem right. Let's unplug this, flip this up and have another look. I didn't see any shorts in the transformer leads. Some of them were chewed on, but it didn't look they were shorted out. Yeah, this transformer's getting warm now. So let's take a look here. So you've got these two wires that go over to tube socket. We've also got, so these two are probably, well, hard to say, I can't really see where they're going. Also got these two wires that go over to the tube socket. If we can get a better look at that. Put this up this way. Show what you can see. So you can see there is some chewing going on here, but I don't really see any shorts. If we can, these over here really don't look bad at all. I don't see any chewing on these wires here coming out. I don't see any chewing on those at all. These look like they would be the low voltage ones, and these would be the high voltage ones. So unless there's a short like on the filament line, I'm not sure. This one, it's like a capacitor, I just clipped out of there. This one's ground and this one's ground. This must be one of these grounds must be for the filaments, one of these grounds must be for the B plus, because the filaments should be 2 volts, I think, filament in here. That's interesting. I could clip these wires off and check the voltage that way. So I really don't see, any other issues here. This capacitor is not in there. Like, you just go to the tube socket and that's it. So unless there's like a short inside the tube socket, which I doubt, because it's a super simple tube socket. So let me just try and separate these wires somewhat here. See if that makes any difference. It could also be, that the filament line is loaded down as well. It's interesting. Let me pop out one of these tubes here. We can also check the regular filament voltage. So there should be, one of these sets of contacts, the filament should have 5 volts on the rectifier. And the other one should be, could be anywhere from like probably 300 to 700, depending on what they want the B plus in this thing. So let's see. I can get the meter in here. That's visible. Make sure this is turned off. Plug it back in. So we'll go back to volts. So these two, I'm getting a good connection here. These should be 6 volts. Oh no, 2 volts actually. This is a 2 volt. This should be 2.5 volts. And we are getting around 2 volts look like. So kind of hard for me to see the meter because the angle it has to be visible in the camera is not visible to me. And try checking these two again. Now, it shouldn't matter, if this winding is somehow shorted to ground, because it should have no reference to ground. Without the tube in, there's not going to be any rectification from the, the B plus windings to the filament windings. So if this was shorted to ground, it shouldn't matter because right now it's just floating. Once the rectifier tube is in, it'll rectify B plus to this winding. Yeah, 2.2 volts, so that's low. I'm about ready to just cut all the wires off the base of this tube socket and test them individually. So 2.2, this is, yeah, that's wrong. So something's wrong here, very wrong. Alright, I'm gonna just cut the wires off the base of that tube socket and test them each individually. Well, not individually, but as pairs. Because that's the only thing else that I can do, otherwise there's a short in the transformer somehow. Okay, so for now I just clipped off the B plus windings, let's just see. Oh, same thing. Alright, so I pull the power transformer completely out, and with it out, and I plug it in, and she's still making that, humming noise, and, come to think of it, 11 ohms for that B plus winding does seem kind of low, so I'm thinking that that might be shorted in some way. Of course, this is riveted together, so, this thing's already toast, nothing to lose. I'm probably going to drill these out and just, so I can figure out what happened to this thing. But I think we now know the reason why this radio was put away without the tubes, because this power transformer, this thing's really hot now, this power transformer probably failed, and so they pulled the tubes out to maybe use in other radios and shelved this thing. So yeah, so that's why never replace like capacitors like this until you test the radio, because if I'd gone through and recapped all these, like look how nasty some of these are, these old tarball capacitors from RCA. Like if you go through and replace all these capacitors, now you've just wasted all those capacitors when you've got a dead power transformer. So, yeah. The only thing that I put in here is power cord, which I can easily take that back out. That's not a big deal. This is a used power cord anyway, so. But yeah, power cord, easily take that back out. And that little bit of wire there for the grid cap, and that's all I put in this so far. So unlikely I'll be able to fix this, and if I can't, I really didn't lose anything on this. So, and surprisingly, it looks like even the pilot light is still good, which is very uncommon in these old radios, especially this old. So anyway, we'll take a closer look at this thing. See, it's full of tar, so that's going to be lovely. But interestingly, only one side is full of tar. You can see that side's pretty empty, and that side's all filled up. So, wonder if they had this like on a slightly unlevel surface, and when this thing got hot, when it was shorting out, all the tar ran to one side. You can see if you look up through there, like it's not solid, just tar pooled down by the bottom. So anyway, I'll have to drill out these rivets here either side, pop this thing open and take a look. Alright, so took the transformer out. I already peeled the paper, like this paper here. Already peeled off this side, but you can tell that this thing is cooked because these wires are all loose in here. Like I was able to pull these. You can see how loose this one is. The real fine strand there. Like these are supposed to be, solidly mounted down in there, and they just pull right out like that. So, yeah, this thing's definitely been cooked, and I'm not sure if you'll be able to see it. You can kind of see the cookage. Not sure if it'll show. I don't think there's enough light. But if you look down in there, you can actually see a bunch of like broken wires, almost like it burned through some of the windings there. Yeah, it's not going to be quite bright enough. I would like to get down in it, but unfortunately this winding is covering it. I guess I could cut that winding out. I don't really like to do that, but I mean the thing's dead anyway, so I guess what more damage are we doing? And you can see, the difference in the thickness of the wire here. So you can see this stuff's really thick, so this is probably either the input winding or the filament winding. This stuff's slightly thinner, so this might be the rectifier filament or something. And you can see in comparison then, this stuff is super, super thin. So, the thickness of the winding is proportional to how much current they expect it to carry. So, actually I'm kind of thinking this is probably the filament winding here, or maybe this is the input winding or something. These are the input wires here, so maybe they got another winding underneath this winding. Kind of makes sense though, right? If this is the filament winding, this is supposed to be 2 volts. So this is, this many turns, or however many, I'm not going to count them, but, this distance of turns with the thick wire, then about the same distance with a thinner wire, so more turns, so more voltage. So this is supposed to be 2.5 volts, and this is supposed to be 5 volts. That would make sense. You've got quite a bit of current for your filaments because they're all in parallel. Probably a couple amps there. then maybe, you know, 1 or 2 amps for this, for the rectifier filament, so a slightly thinner wire, and then, you know, only maybe a couple hundred milliamps probably for the B+, so that's why it's this super thin wire. And this stuff, not sure, but you can see how solidly these are mounted in there. Like, I'm tugging on this and it's not moving at all. So this winding is not cooked, but these things being so loose, you can definitely tell that's been cooked. So I don't think there's really any hope to save this. You know, even if you could try and, like, you know, remove the short and just like have it as a dead winding and maybe use it as a 5-volt transformer, you couldn't even do that because this winding is in the way. Wonder if it'd be worth it to use this as just the 6-volt or the 2.5-volt transformer for the filaments, and use like a voltage doubler or something for the B+. You wouldn't need this winding either. I don't know. You know, this thing's completely dead, so I'm just trying to think of something interesting to do here. Instead of just put it in the garbage, because that's not interesting. So maybe I'll play around with this a bit. Maybe I will cut this winding out. Kind of just want to see this thing work, even if it's just, you know, producing 1 voltage instead of the 3 it's supposed to. But so yeah, definitely cause of death there. Transformer is fired. It's usually not actually that common to see this, really. I think I've only ever seen like 1 or 2 completely dead transformers like this the entire time I'm working on radios. So yeah, you know, and usually when transformers do fail, they go open, but this one's actually shorted, so that's interesting. And I'm going to cut this. I'm just going to look at the carnage. See if I move this closer, you can watch it. Or even though I've already made a tar pile on the floor. So let's see if we can just cut through here. The other thing's already dead, so, you know, this is mostly exploration at this point. Gonna figure out why it's dead. Oh, no, it didn't cut. It's a kind of interesting smell. Almost like, you know, when you go to the museum and see all the old machinery, it kind of smells like that. It's tar. Okay, so that winding's out now. I can peel some more of this. Oh yeah, icy charcoal. Sure if the camera's gonna pick it up, but it looks like charcoal there. This stuff looks pretty well charred. I'm surprised these fine wires are still attached to you. It won't be for long. Did this one break yet? No, even that one's still attached. Dump some of this garbage out. Looks like one of them fell off now. Okay, so there's a bunch of crap in there yet, though. Wondering if I can just like, I don't really see, you know, there's like it's charred on top there, but you can kind of see the windings, some of the windings there. This is the cenotap here. This would be one end. So yeah, that one continues on there. Looks like the other end has detached itself. Where's this wire right here? So yeah, that one goes down into the center. This one will come from the center, and then this is the outside one right here. You can see that that's loose and going around the corner to the other side. So this whole thing is pretty charred. I guess what we could do is just start cutting. If we cut, and now we're just not a whole bunch more tar on the floor. See if I can get a better view here. Okay. So let's see if we just start slicing. So we can see, so is this actually wire? I can't tell if that's wire or paper over the wire. That's wire for sure. I guess we'll just start, peeling back one layer at a time. See if we see anything interesting. This is not going to look like I want it to. Although I guess I'm not going to go like super far in. This is quite a bit of wire here. I don't have to cut, 20 or 40 or 100 layers in. See if we can. I hope this knife will work better for this. But it is not. It's not at all. Well, it kind of is. Yeah, I don't think we're gonna find anything here, to be honest. It could just be that the lacquer, on the outside most layer failed and started shorting to like the center tap connection or whatever. Because what they do is see, are any of these still attached? Probably not. Here's one. So like what they'll do is when these are all like finished being wrapped, they'll put like a layer of paper or something and then lay these on top like this and kind of like tar them in place. So, if the insulation between this and this outermost winding failed, then that would be a short, because this is this is the center tap. This is going to be a much different potential, maybe 2, 3, 400 volts different. So if that, shorts or gets leaky or something, current's going to flow from here to the outside winding if that insulation starts breaking down. So maybe that's what happened. These inner layers look slightly less black, so I wonder what would happen if I just cut all of these off and apply power to it. If it will give us at least 6 volts. That would be interesting. That could happen. I don't know if I would use the transformer in that state, but just kind of curious at this point. It could be potentially saved for anything. This is just an experimentation. I don't really expect anything to come of this, but it would be cool actually if we could get the transformer to output 6 volts and then use some kind of voltage double or something for the B+, because then we wouldn't need the 5 volt winding or the B+ winding. Well, these are pretty hot too. You can see how the copper is a different color there, so that's interesting. This whole thing looks like it's been cooked. See just how many layers of windings there are here to develop that voltage. And all the crap that's coming out. That charcoal. I don't know if I'm going to film this whole thing. I don't expect to really find anything super exciting here, but I don't think we're at the center point yet. That wire is still attached. And you can see how the copper is almost a red color because it's been cooked. Let me get in this for you. Yeah, interesting. Not 100% sure what the failure is here, but something shorted. So you know what? My initial theory about these shorting out against the outside of the winding wouldn't make sense because even when I pulled these out, it was still shorted. So something internal. And it wouldn't be like a short to ground because even if, you know, one winding, like one of these wires here shorted to the transformer frame, that wouldn't develop any like potential, but like just then the transformer frame would be at that voltage. Like that wouldn't really be a short, you know, unless they've got something else connected to the transformer frame, which I kind of doubt. Because I exposed the ground leads out the bottom, so you can connect to whatever you want, so it wouldn't make any sense for them to internally connect anything to the transformer frame. So yeah, I'm not too sure what happened here, but something's definitely been cooked. So that red color in the copper, getting close yet. And there's no way the mouse could have got in here. Like this thing is, you know, sealed up from the bottom. There's no way the mouse could get in here to do any damage. Yeah, so look at that. So look at the color of the copper here. See how it's like the nice color, copper color? And look at it here. See how it's all red? Because I guess that could theoretically be the lacquer coating, but and as you can see, like even on the ends here, they look red. That wouldn't be the lacquer. Alright, looks like we might have reached the bottom. So I think what I'm going to do now is apply power to the primary. Maybe monitor the filament voltage and see if it outputs 6 volts. Because that would be interesting if it does. Or it could just erupt in a ball of fire. Which would also be interesting. Not ideal. None of these are going to touch anything here. Okay, so this is not recommended. I've got my voltmeter on the 2.5 volt winding. I think I keep calling it a 6 volt winding. That's just because that's what the filament winding usually is. But no, in this case it's 2.5 volts. Was the old standard before they switched over to 6 volts. Got some clip leads on the input winding. Verified that it's not shorted, it still has continuity. Verified that the filament winding still has continuity. So let's see what happens here. So you can see that meter. Just no loud hum, and it's working. What do you know? Okay. So, the question is, what do we do next? What I could do, well, I'm unplugged again now. What I could do is do kind of the same thing on this side and cut here and pull all the windings out. If I'm going to use this for anything, which I'm kind of having an idea to do. So yeah, I could take the winding, cut the winding, same thing on this side, see if I can pull all of this old wire out of here. And then I'm going to get to thinking about how I want to rig up a voltage doubler, just to see if we can get some sound out of this radio. This is not worth it, obviously. I'm just doing this for fun now. See what we can do here. Like I said, we got nothing to lose. This thing's already toast, so with that fix I already had to do on that IF transformer, and now this, we're just having fun at this point. But yeah, so if I cut here, I can remove the windings the same way this side. I'm not going to make you watch that. These wires here are for the rectifier filament, which we've already cut that winding, so no sense in leaving those attached. So yeah, I think I'm going to do that, and then we might have ourselves a good 2.5 volt transformer. You notice that the output was a little bit high, it's like 2.8 or something. That could be for two reasons. One, we don't have any load on it, so that's just open circuit voltage. Normally there would be, I think, 4 or 5 tubes. I think it's 4 tubes. Yeah, normally there'd be 4 tubes load on this thing, so probably a couple amps draw. So it may drop down with that. What I could do is hook that winding up and see, just for fun, if I hook this up to the filament windings in here. I think one of them is supposed to be ground, but for now we'll not worry about that. That should only matter once everything's hooked up for cathode return, so since we have no B+, that shouldn't matter. Let me see if I can strip these wires real quick here. These stupid capacitors out of my way. See if I can hook up both my meter leads and alligator clips here. This thing's all tangled up. Always the case. Alright, so that should be at least 3 tubes, one of them's out. Let's do a test here. It's still kind of high. So I might have to add like a load resistor or something to drop that down. Let me pop this other tube in real quick here. This is the output tube. Also, that the tubes are making bad connection too. But yeah, still a little bit high. So part of the reason for that is because there's not the additional load on the transformer of the B+ and the rectifier filament. So like all the magnetic coupling is just to that one winding now. So it's going to be a little bit high. So we'll have to think of something to drop that down somewhat so we don't roast our tubes. Yeah, maybe, just maybe, we'll get something out of this radio. Okay, so quite a bit has happened off camera since I last shot this segment, but let me try to explain what happened here. So first thing is I made a slight mistake. I was checking the filament voltage before, measuring like around 2.8 or something. So I counted the number of turns here and divided that by how much voltage would be developed. I counted the number of turns here and divided 2.8 by that to calculate how much voltage was developed in each turn. And it came out to around like a little bit over 200 millivolts. So I decided to sand off the tar from 2 layers and just blob some solder over them to short them out, which would basically be taking 1 turn out. So it should be dropping the voltage by 200 millivolts. And it did. When I turned it back on, it was around 2.6 filament voltage. So I went on to check the tubes and realized that the tubes weren't glowing because I was hooked up to the wrong wires for the filaments. So I undid that and I melted some tar back over there to electrically isolate them again. Then I connected to the correct windings for the filament and actually got about 2.3 volts, which is, according to the schematic, because I did find a schematic for this thing, according to the schematic, it's supposed to be around 2.3 volts for the filament voltage. So actually this transformer will work in its current state with, should be no issues, correct voltage and everything. I was just hooked up to the wrong voltage, to the wrong wires before in the radio, which is why it wasn't loading that 2.8 down to the 2.3 that it should be. So rectified that, should be no harm there. I've installed in the radio, it's gonna be kind of hard to see because it's kind of just hacked together for now, my voltage doubler. You can see one diode, there's one diode right here. If I can get this in shot, what am I pointing at? See, there's one diode right there, and then you can kind of see the other one down there behind it. And then this capacitor and this capacitor down here form the voltage doubler. So there's two diodes and there's two capacitors forming the voltage doubler. I measured the voltage coming out of their open circuits. It's around 330 volts. According to this schematic, they want 275 at the rectifier tube and 250 for the main B+. So I've installed these, I installed two 3.3K resistors in parallel. According to the schematic, the current draw will be anywhere from like 40 milliamps to 60 milliamps. So I kind of went with like the 40 milliamps and how much voltage we needed to drop and came out to around 1.5K-ish in that range. I don't have a 1.5K with the right resistance, so we'll just go with these two 3.3 in parallel, which would be, what, like right around like 1.7K or something, so that should be fine. We'll see what the voltage is. I got this meter lead here resting on the B+, so that should do that. I've got the transformer winding hooked back up. And just let me be clear, this is not a recommended repair. This is just kind of like, can we do anything to get some sound out of this radio? Because essentially what I'm doing is turning this into a hot chassis set. And that's how voltage doublers work, right off the AC line. So I now have one side of the AC line connected directly to the chassis, which is, of course, this is a polarized plug I've got on here now, so it's or it should be the neutral side of the polarized plug, but even so, this is not designed to be a hot chassis set, and we're making it a hot chassis set, so this is not a recommended repair. Just because I've connected the neutral of the power cord to the chassis doesn't guarantee that the chassis will actually be neutral, because someone could have wired the plug wrong or something, so like inside the wall. There's no guarantees that just because you connect the neutral side to the chassis that the chassis will actually be neutral. But anyway, so yeah, this is not a recommended repair. This is just seeing if we can get anything working here, just for fun. So anyway, let's move this up into the shot in case something explodes. So when I plug this in and turn this on, this should immediately go to like 330 volts because there won't be any load until the tubes warm up. So that's why I went through and replaced all the older capacitors. You can see I've got, well, not all of them, but the electrolytics anyway. This is the 10 microfarad here, and there's two 4 microfarads down there. Yeah, I went through and changed those because, like with the rectifier tube in there, that'd be kind of like somewhat of a slow start to the B+, so if the caps are somewhat leaky, they might have like some kind of a chance to reform, but in this setup, we're immediately applying the full 330 volts. It would be somewhat less because of this resistor here, so it would be some drop across that, but still, didn't want to take the chance with those old capacitors going to blow up or something, so anyway, let's plug this in. And we are expecting to see 330 volts or fire. Let's see what we get. We get voltage. It's rising, so probably something had to charge up a little bit. Now it's going to drop as the tube is rolling up. Okay, so that resistor, definitely my calculation there was wrong. 90 volts, yeah, that's not going to work. So I'm going to have to do something different with those resistors. Clearly I miscalculated something. Don't hear anything. I did check, it could just be that, yeah, that's probably way too low, so we're probably not going to hear anything like that. Okay, let me see if I can, like, jump without those resistors or something. That's way too low. 62 volts. And then what do we have on this side? We have 218. Okay. So, actually dropped more than I thought it would. This is like right off the... I wonder if I have a high resistance connection in there or something. Okay, so nothing so far. Now let me see if I can jumper out those resistors real quick and see if that gets us anywhere. Alright, so I just quickly started a wire across those resistors. Let's see what happens this time. Might help if I actually put my test lead back on there. Let's try that again. I got 172. Still low. Something is off here, I think. Yeah, this voltage should not be dropping this low. I forgot like a bad connection to my voltage doubler or something. That's way... That shouldn't actually make any difference, really. That's interesting. Wonder why. 75 there, so we should have about 75 here. 160. Okay, so all that drop is across the field coil then? That's interesting. What's the voltage here? 120. Am I testing the wrong end here? Voltage here, 74. I must be testing the wrong B+, that's probably part of the problem. Voltage here is... Come on. $120. That's still low. It should be 250. Not hearing anything either. So we have 119 there. We have 164 there. That's quite a drop across that field coil. I could double check the resistance of that, but I checked it before and it wasn't open. And obviously it's not open because there's current flowing through it. Of course it could be too much current. I have no idea, what the state of the rest of this is. So let me double check my connections in my voltage doubler and make sure that one of those isn't like high resistance and causing this drop. We'll see what happens if I can figure something out there. Alright, so I think the issue with my voltage doubler is that I didn't use large enough capacitors. I was using 10 microfarad. Right now, just across one of them, I tacked in a 68 microfarad. Just across one, because the other one's very down and I can't really get to it easily to tack something that big in. But just with that quick experiment, my voltage went up considerably. So, if you use capacitors that are too small here for the current draw, basically what's going to happen is, because the way that these work is, like each half of the sine wave charges up one or the other capacitor, and then, the draws off both the capacitors, like, when neither of them are charging, and the zero crossing point and so on, or when the sine wave voltage drops below, the capacitor voltage, then they'll stop charging, and then the current will flow out of the capacitors or start discharging into powering the circuit. So if the capacitors aren't big enough, then they'll discharge substantially, on the not charging part of the sine wave. And when that happens, then when you filter it with the other capacitors after the voltage doubler, it's going to filter to a lower DC voltage because the capacitor, discharges so significantly on its discharge part of the AC cycle. I hope that makes sense. But so by increasing the capacitor value here, we're giving it a lot more charge so that on its discharge cycle, it's not going to discharge as far and will maintain a higher DC voltage once filtered. So this is probably not going to either because now I've got an imbalance in this voltage doubler. So that capacitor that's buried down in there is going to be discharging a lot further than this pair is here. Right now that's kind of advantageous because when I checked the voltage here, it was around 280 volts, which is a lot closer to what we want to be. Versus if both of these were at full voltage, it'd be around 330 volts, which is too high since I got these resistors jumped out. So yeah, this is getting into like super hack mode, but let's just turn this back on and see if I can get at the right point here. I'm testing it right. So we are plugged in. 270, so yeah, that's a lot higher. See what it drops to when the tubes start warming up. I should be sure unless something is horribly wrong. My tube is not warming up. They're not warming up because I have the power transformer disconnected, so I just soldered that capacitor in. So this was disconnected because it goes, let me unplug this before I shock myself since I have to reach down in here. So this goes right there on power switch output, and that feeds the voltage onto the filament transformer. Okay, let's try this again. So now we should start dropping as the tubes start warming up. The tubes actually should start warming up this time. I see them glowing, that's good. Yes, now we're dropping as they start conducting. See how far we drop. And it's still dropping pretty far. Farther than I would like. So it's still about 100 volts low. See what our voltage up here is. 211. So I might need to bridge across that capacitor I know with a bigger one too. I think this connection right here is supposed to be the plate of the output. It's only 138. What are we at here? 150, so this, 20 volt drop across the output transformer? It's probably not too terrible. I still don't hear any audio. I don't feel the speaker vibrating at all. So obviously the output transformer has continuity because, otherwise you would have no voltage on here. This is the plate circuit. So if this has voltage here, then current has to be flowing through the output transformer. Could mean that the voice coil or something is open. When I checked resistance on the secondary, I only checked like across the voice coil, so that would be the output transformer and the voice coil in parallel. I tried another speaker, hook that up and see if we get any. I don't even feel this thing vibrating, like no hum, nothing at all. Now it could be that that voltage is not high enough to get anything, any drive out of that tube. Field coil is definitely magnetic because I can feel it. it definitely attracts my screwdriver. So there's definitely, good magnetism coming out of the field coil, but there's literally no vibration whatsoever coming out of the speaker. So let's see, what can we do here? We can either try and increase the voltage by adding some more filtering in the voltage doubler, or we can try a different speaker. I think we're going to try a different speaker first just to see. When I checked the resistance of the voice coil and output transformer secondary in parallel, it was around, almost like 0.2 ohms, which usually that's the resistance of the transformer secondary, and the voice coil itself is usually 1 to 2 ohms, which is not the same as the impedance. And if you DC measure the resistance of like an 8 ohm speaker, it'll be a lot less than 8 ohms. But anyway, so let me find a different speaker. We'll try that first. Alright, so new speaker has been attached here. I don't know if this is going to make any difference. I did check the voice coil and it does seem to have continuity. So both the output transformer and the voice coil have continuity. So it's really weird that, there's, like, even if that tube wasn't driving, I would still expect to feel some kind of, vibration, just a little bit of hum out of that speaker. But, okay, so everything should be back connected here. Turn this on. Not getting anything at all out of this speaker either. Oh, a little bit of hum now. A little bit of vibration out of there. No sound, but a little bit of vibration I'm feeling out of the speaker now. So, see if we. A little bit of scratchiness when you change that control. There's the tone control, by the way. This volume control doesn't actually affect the output circuit at all, and this just changes the bias on the RF amp and oscillator tubes. So wouldn't get any scratchiness here you wouldn't expect to hear, or at least I wouldn't expect to hear it in the output. So it has to make it all the way through all the stages to get to the output. So the fact that this is doing nothing doesn't really tell us anything. The fact that that's somewhat scratchy tells us something. Yeah, I think that just this voltage is too low, 139 volts. I think that's just too low for us to get anything out of here. So let me play around with this voltage doubler. Maybe I'll make it a triple if I have to, and see if we can get some better voltage here. Alright, got another capacitor, 68 megafarad installed across the other 10 down there. Just see if that makes any difference. It's still dropping too fast. Somewhat better, but still 50 volts low. What the voltage is on this here? 77. Doesn't make any difference, no. Well, let's turn the capacitor. That tone capacitor is not leaky. No voltage change there. Thinking is still too low. course, it's kind of hard to tell, you know, because if this transformer here is not letting anything couple through, then you know it could also be an issue. I'm not hearing anything because, like I said, the volume control only affects the RF and oscillator stages. It's not getting anything from there. I'm not getting any noise at all except when I change this control. I'm not sure. I don't think the camera will pick it up because the control is pretty loud, so you don't really hear the scratchiness. Tuning does absolutely nothing. Alright, 185, still way too low, so like 70 volts low. So yeah, let me see if I can raise that. Oh, so the hack together voltage doubler is now an even more hack together voltage tripler. Let's see what we get this time. So that's quite high. Expecting that to drop somewhere as the tubes start warming up. That's actually right at the limit of my capacitors, so probably shouldn't do that, actually. I think these capacitors are 450 volts, and that was just 5 volts over that, so that's not a good idea. Let's just see what this gets us now. Secret meter is about to turn off. It should be 250 volts. 280, so that's high. I don't really hear anything out of the speaker. That's interesting. What our voltage is here on the plate of the output tube now. 240, so that's pretty close actually. That's supposed to be 250, I think. Double check that, but yeah, right around there. So that's pretty close to what it should be. I believe this capacitor here is what. Ooh, we have activity there. So yeah, this capacitor here is what couples into that tube. 122 volts. That actually is probably right on this side. Oh, come on. Alright, so we have activity there. We have nothing there. Nothing there. Nothing there. So I wonder if that tube is not functioning. That tube. Alright, so here we are here. This is the output tube. You can see there's the output transformer there. So right here we've got, this is the one side of that control there. Right here we've got, is it like 250 volts or whatever, 240 volts I think it was. That's the output tube. This is that capacitor I'm poking that couples into the grid. So poking this side of the capacitor we have activity. However, poking over here we have nothing. So maybe I wonder if this coil is bad. This is an RF choke. See if I can. Well, the problem is the other side of that coil is all the way down underneath. Not sure that I can get to it. So this is that coil right here. To be honest, I don't think I checked that one too closely, but if that is open, then we would not be getting any B plus to, I think this is the detector tube. This video is weird, it doesn't have an audio stage. The detector tube drives directly into the output tube. So, that's interesting. Not sure if I can, let's see, that would be down here I think. So right here we have 127 volts, which is probably not unreasonable because that goes through a 200k resistor and a 50k resistor, so that will drop that somewhat. Let's see, what do we have here? That's a problem. Okay. So I'm betting this RF choke here is open. Didn't really notice any damage on it though. For testing right now, we can probably just jump that out. Should get like just an RF choke, so you still get some audio even with that jumped out. Okay, let's jump that out and see what happens next. Alright, so I just quickly jumped out that coil with a piece of wire. It's only 100 ohms, so I don't think it should matter a huge amount. Let's see if we get any sound this time. We're going to do something different here with that voltage up, because that's way too high for those capacitors. Not supposed to get that close. Well, that's over the rated voltage, but you're not even really. Ideally, you shouldn't get that close to the rated voltage anyway. I probably wouldn't want to go over like 420 or something. Still not really getting anything. Oh, so now I have some audio here. We don't have any here though. This is the good cap of that tube. We have some there. Not very loud, but it seems louder here. That's interesting. It seems louder there than at the good input of that tube. I don't know what that is. That's interesting. So this goes right to the grid cap. Are there anything in there? This is the other side of the coil. 81 volts? 81 volts on the grid? That doesn't seem right. Could be a problem. Let's see, what's connected to that grid? So we're looking at this tube right here. So this is the coil that I just shorted out that goes to the plate. The grid, which goes to the cap, so that's that IF transformer that the mouse chewed on that I pulled some couple windings off and reconnected it. So there's a capacitor here that looks like it might go to the plate. I wonder if that's leaky. And then a 1 meg to ground. So that's probably, let's see, that would be this guy right here. Let's clip that guy out and just see what happens. And find my clippers, that is. Not sure where they went. There they are. It's a good place for them. So let's see. Right now here we have 80 volts. If I cut this capacitor, we have, well, that seems a lot better. You can almost hear now some interference. There's some activity from that side of the coil. So volume's all the way up. It's not really. Okay, so right there's something. Not sure if you can hear that or not. Tune off of it. There's something there. I was picking that up. It's working, kind of. It's super faint. I don't know if I'll pick it up or not, but that's super faint, but that is a radio station. So we are getting somewhere. So what's next? There's probably more of these capacitors that are bad. If we can see if there's any other. Yeah, so there's one of those used on the grid of the RF amp. Looks like the RF as well. So yeah, so the capacitor. Let's see, actually. Okay, no, I was looking at the wrong thing. Okay, so this is the one that we cut right here. Goes from. What is that? So this is connected to. It's connected to the screen. That's interesting. Why would that cause that go up to 85 volts? Which doesn't make much sense now that I think about it. But it clearly was doing it because when we cut it, the 85 volts went away. So I wonder if this tube is messed up or something. Because this should be connected to ground. This is the suppressor grid. It's kind of hard to see where exactly these wires are going. It looks like this is the suppressor grid and goes to there. Also goes down through a resistor to ground. So why would that be at 85 volts? That doesn't make a whole lot of sense. Anyway, they got a similar setup here on the RF tube. See another 0.1 back to the grid there, goes up to the suppressor grid. So I wonder if we can check the voltage on that. Probably not because it's buried all the way down underneath there. You can't get to it. But actually, if this has a grid cap, we can get to it. Let's see. It's on volts mode. There's a grid cap here, and there is one. Let's check the grid of the mixer oscillator. That is at ground, so that's fine. Check the grid of the. That's ground, so that's fine. Now this is at just about ground, so that's fine. Notice how much sensitivity there is here. That's just me touching the grid cap. So I'm wondering, actually, if we adjust this here. I'm just going to play with this. Tuning capacitor, or this IF transformer. The inductance of the coil goes down. The capacitance of the capacitor should go up to compensate. It's the resonant frequency. So we've opened those up quite a bit. Let's just see if that makes any difference here. No, not really. So let me see if I can play around with that IF transformer. Who knows? It could be that the coils now are so far out they won't even tune those capacitors anymore. So it's definitely a possibility. Is it the only IF transformer this thing has, actually? You know what? There might be another one. Actually, no. This is the only IF transformer this thing has. This would be like tuned RF here in your mixer oscillator. Then this right here would be your oscillator coil, and this is that one IF transformer. So that's all we've got. So definitely can't bypass this thing or it won't be a super header anymore. So let me play around with this for a while and just see if I can get any better results than we were getting. Alright, so we're getting somewhere.
Captain William Cunningham, the provost marshal, commanded the jails and prison ships holding American prisoners.
That's volume all the way up.
The Sons of Liberty.
Our tape was off pretty fast, but we're getting somewhere.
He enjoyed torturing people. According to Burroughs,
So it's tuning, we're not getting any more stations up there.
prisoners by starvation, hanging.
Breaks into oscillation here for some reason. I'll show you what I'm doing here. And there's really nothing at the low end either. There's kind of a station there. The oscillation is messing it up.
United States to be free and independent states. The articles were proclaimed in the King's name from the steps of the City Hall on Wall Street.
So what I've done is I was kind of concerned the ratio between the main B plus and then it goes through this dropper resistor to a secondary B plus, which is for the screen grids. And I was concerned that the B plus was right on where it should be, but the screen B plus was higher than it should be. I think that's supposed to be about 95 volts, and I was measuring like 150 or something. So what I kind of figured and what I confirmed was that the capacitors in the output circuit were fairly leaky. Actually, they were more leaky than I had imagined. In fact, this one here, which is the grid coupling capacitor from the plate of the detector to the output grid, was actually getting quite warm. So I just went and I changed those, and the voltage change was actually quite amazing. If you remember before, like when we first turned it on, before the tubes warmed up, it was like right around 455 or something like that. Well, with those capacitors changed, it went up to like 475. So even without the tubes conducting, 20 volts was being drawn through those leaky capacitors. And then of course, once the tubes warmed up, then they would throw the biases off and cause, some of the tubes to conduct too hard, especially the output tube, which would, draw more voltage. So I took those out, and the voltage difference was so different that I actually changed this back from a tripler to a doubler. And I'll get my meter set up. You can see there. So the main B plus right now is measuring 223 volts. So it's a little bit low. It's much higher than it was before when we were testing with the doubler. Before it was like 150, 160 or something. So definitely improvement there. The secondary B plus for the screens, I think that's still too high. So I think that my current hypothesis is something is throwing off that voltage. God, hate this meter. Something is showing off that voltage, which is causing, because when the screen voltage is off, the tubes are going to conduct differently than they're intended to, because that screen voltage has an effect on the tube conduction. So could be that because that voltage is off, the tubes are conducting more than they should, pulling more current, and that's what's drawing the B plus lower. Could be what's happening. Because if I turn this stupid meter back on, and then go right off the doubler, I have 294 volts. So that means that the field coil would be dropping, what, like 70 volts then? This was 230 something, right? 223, so yeah, the field coil is dropping like 70 volts, which I don't think that's quite right. I could be wrong, but I don't think that's quite right. Especially because given the schematic, says that rectifier plates are supposed to be like 275, and then the main B plus is supposed to be like 250. So that would only involve the field coil dropping like 25 volts, not 70. So something is still off here. But we are getting somewhat better. Turn this off. And yes, this is not the correct way to stand up a radio while you're working on it. It's really the only way that I could stand it up, because with this power transformer out, this thing is really unbalanced, and I need to get a look at this side to check here. And you can't stand it up, on this end, because without the power transformer, that'll just flop right over on top anyway. So, anyway, yeah. This video is not a how-to video. This is just, let's see if we can make this thing work. So, we are making progress. It picks up 1.5 stations now, and it's actually audible instead of, you have to shove your ear into the speaker to hear it. We solved some of the voltage issues and went back from the tripler to the doubler, so that's, somewhat more sane. But there's still something off here, so I'm going to play around with this some more, see if I can get this to be, see if I can get my voltages right, and then when that's right, see how this performs. So yeah, so capacitors that were replaced, there's that one down there is the grid coupling cap. Then these two are also in, this is some kind of weird resistor network. I'll show you that in a minute. And then this one here is in the grid circuit of the detector tube. This one I clipped out before because it was leaking, causing a voltage imbalance, but once I changed these and got the voltages more correct, then as soon as you turn it on, it would start howling, so I had to replace this one. And yes, it's not started incorrectly, and the reason for that is because I got these supercapacitors with super short leads, so they don't reach to anywhere, so that's why that's like that. That's not permanent. Like I said, this is not a how-to video. So yeah, let me see if I can figure out, actually let me show you the schematic here of what actually was changed. So what actually was changed was this guy right here, this guy right here, and this guy right here. So this is that coupling cap I was talking about. So it goes from the plate circuit here of the detector tube, couples to the grid of the audio out. So this is the one that was getting hot. So a significant current is flowing through that capacitor to the grid, causing a voltage imbalance. You see that? Causing a voltage imbalance, not imbalance, but causing the grid voltage to be too high, which then causes the tube to conduct more than it should, which of course is going to pull more current, and then it'll drag the B plus down. These two here, there's just some kind of like filter network, I guess. You can see this one goes over to here and then goes to that one to a resistor to ground, but also goes over to this resistor to ground, which I think is on the cathode. So I'm showing this here. So these two are leaky, which would pull excessive current up through this resistor and would also help in throwing off the bias on this tube because they're connected to the cathode. So all that's been changed, and the other one was this one right here in the grid circuit of the detector tube. It looks like it goes to the cathode and the suppressor grid. And I think I clipped that one out before because we had a weird voltage on the grid. But without this in here, once I replaced these, it just howled like crazy. So I had to put a new one in there to stop that. So yeah, I think there's only one more paper capacitor in here. And let's see, I think it's over here somewhere. It's off the oscillator can, I believe, which is this can right here. Does that make sense? It's not that one, that's micro one. Here, it must be this one, yeah, 0.1 right there. So that's that one. So that goes through a 20,000 ohm resistor. Showing that goes up to this resistor to that capacitor. If this one was leaky, I wouldn't expect the entire B plus to be low because it's on the other side of this 20,000 ohm resistor. So even if that's drawing excessive current, you'll be severely limited by that resistor. So I'm not sure that that's the issue. Yeah, so let me check what the voltages are supposed to be. So actually, let me show here. So if you look here, this is where the B plus comes in through the field coil with the filter cap on each side. And then through this resistor divider network here. So it's 14,000 ohms and then 14,000 ohms and then the volume control. So this line on top is the main B plus. Then after 14,000 it goes to this secondary B plus, which is for the screens, and this I think is too high. It's higher than it should be. And then it goes to another one to this, and this is the cathodes, I believe. And then this is the volume control. So this adjusts the voltage here on this line, which is the cathodes. You can see it goes up here to the cathode there, over here to the cathode here. And so that's how they're controlling the volume here by adjusting the bias of the RF tubes, the RF amp and the mixer oscillator. That's how they're controlling the volume. So the audio section always runs like as a wide open amplifier, and they're controlling the audio signal basically by the gain of the RF section, which is not super uncommon on some radios from this time period did that. It's just weird by modern standards to do it that way, but that's what they're doing. So right now with the volume all the way up, it should be at a minimum. So if I'm thinking correctly, this should be at a minimum resistance. There's a 100 ohm section, so this always has a minimum 100 ohms. So this should be 100 ohms, which would give I'll make the grids the least negative, because that would pull the cathodes close to ground. I believe the grids in this thing are always at ground. See if I can find where the grid here goes. Yeah, so see the grid on this tube goes up over through that coil end to ground. So the closer you get the grid voltage to the cathode voltage, because the grid should be somewhat negative, like with respect to the cathode. So, if the grid and the cathode were equal, the two would be biased on too hard, so the grid has to be somewhat negative, which is why they have this 100 ohm section, so you can't get the voltages too close. But the closer you bring the cathode down to the grid voltage, the harder you drive the tube. So by turning the volume up, you'd be turning it up to this 100 ohm section, so that the cathode voltage would be as close as possible to the grid voltage, and would bias the tube on as hard as possible. And it looks like also that would draw this B plus, secondary B plus down somewhat. So this should be at a minimum too, and it's still too high. So I gotta check into that, see if I can figure out, maybe this resistor here went high or something. See this one here, maybe this one went high or something, and it's throwing off the divider or something. So we're gonna check into that. I think I showed on the schematic that secondary B plus goes right to the screen, and you can see here, this is sideways, but here we go. So on all these tubes, cathode to screen grid volts, 95, 95, 89, and this is 235. That doesn't make a whole lot of sense. I don't think anyway. Cathode to plate volts, so I'll have to check that out. But either way, this is not quite where it should be according to what I'm measuring. I'm getting 235 there. I think these are all connected to the same line. Let me double check that actually. No, they are not. That makes sense. So you can see on this output tube, the screen grid is connected directly to the B+, so that makes sense. That's why. So that's why this one has a higher screen voltage. But all these other ones take this secondary B+ line up to screen there, and the screen there. So the maximum voltage there was what, 89 volts? We've got 135, so something is still not right. I mean, there's obviously a knot that's not right with this radio, but we should be able to get it to perform better, hopefully, if we can get those voltages correct. So I'm going to play around with this a little bit more and see what I can come up with. Alright, so it's a little bit better now. So you got one station there. And another station there, so now it gets 2 whole stations instead of 1.5 stations. Oh, there's some kind of hints. There's barely one there, I don't know if you can hear it or not. So I did put an antenna on this thing because it doesn't have like a built-in antenna really. Engaged in the early 30s didn't have any kind of like loop antenna or anything, so the only option is long wire. So I did put a little bit of an antenna on it. I also replaced these 2 resistors. This one, these were supposed to be 15K. This one was measuring about 10K, and this one was measuring about 30K. So I replaced those there, so I didn't have any 15K, so I just put a 5 and a 10 in the series. Voltage still isn't quite right though. I set this here. So B plus is 230 volts, so that's still somewhat low. This here, however, well, if I got a good connection anyway. So that's 94.8. So that's pretty close, I think, to what it should be. I think it's supposed to be like 95. Let me double check here. Yes, screen voltage is supposed to be 95 volts. So the screen voltage looks good now. Still not sure why the B plus is low then. Kind of interesting actually. No, it could be that someone put the wrong speaker in here. I have no idea. I don't know if this is the original speaker. It's only actually held in by 1 bolt. You can see here. This and this are what's like it's supposed to hold it in. If you go to the back here, only one down there has a nut. So you can see one of the bolts has a nut, and the other one doesn't have anything. There's nothing on that one. So I don't know whether the speaker was replaced. Maybe they put the wrong one in with a different field coil resistance. I have no idea. Playing with the IF transformer. On one side, I can get a peak. There is a definite peak. You know, when you turn the adjustment, so one side of it will peak, the other side will not. When you turn it all the way in, it gets somewhat quieter. When you turn it out, it just gets a little bit louder and then kind of like stays at the same volume. So, could be part of the problem that this IF transformer isn't peaking. So there could be some gain loss across that. You know, if it actually peaked both sides, it would probably have like a higher, you call it Q factor or something, but whatever, you know, because the frequency that's being driven into it is not at its peaking frequency because it's not peaked, or because it can't peak anymore, you probably have some gain loss there, because, you know, the maximum transmission of a tuned circuit is at its tuned frequency. And since we can't achieve that, we're probably losing something there. I have been playing with the RF and both the RF adjustments on the tuning capacitor. They do peak as well. They don't seem consistent across the band though. So like if I peak them at like this station, which you can barely hear, I can adjust those RF adjustments so that this will come in a little bit louder. But then when you turn it up to the high end of the band, it just starts oscillating. So something screwed up there. This switch here, and this is the actual switch, is supposed to be for AM versus shortwave. In AM, I believe none of the connections are closed, so I don't think that should be an issue there. When you turn it to short, then it closes the connections and basically like shorts out some of the coils and the capacitors to engage shortwave. So I don't think this is our issue, since even if the connections were dirty, it wouldn't matter because none of them are connected in AM. So I'm undecided how much further I want to go with this. Technically, it does work as a radio, just not a very good one. So maybe I'll play around with this some more. Maybe I'll just give up and like turn it into some kind of poor tube amplifier. I don't know. The audio stage seems to work. When you tap on this connection here, couples through. So I don't know. I haven't decided how far I'm going to go with this yet, but technically it does work as a radio. I would kind of like to get it to work better, but we'll see. I kind of think that now we might be running into this IF transformer as a roadblock for improved performance. Anyway, we'll see. Might kind of be something there, it's hard to tell. So, it does work, but just barely. This is going all the way up. So as soon as you turn it down just a little bit, it goes right away. Of course, not all these radios used a log scale pot for the volume control. So that's kind of a characteristic. Sometimes they have quite a bit of adjustment. Like when you turn the volume control, it will change very quickly, like at one end, and then change very slowly at the other end because it's not like logarithmic, which human hearing is logarithmic. But anyway, so that could be part of the reason why the volume control only seems to have an effect at the top. But I think the main issue now is this IF transformer. This meter is very annoying. So anyway, it does work, just not very well. So I think what I've decided to do here is I'm going to call this a success on the power transformer. We were able to successfully cut out the shorted winding, use the good filament winding, and rig in a voltage doubler for the B plus circuit. And that part seems to be working fine. The tubes work fine, the B plus is there. It's a little bit low, but I don't think that's the voltage doubler's fault, because like up here, right off the voltage doubler, we're measuring around 300 volts, and then quite a bit of voltage drop is happening across the field coil. So I think that's more an issue with the radio than an issue with the voltage doubler. So I'm going to call the power transformer hack a success, but I'm going to call the IF transformer hack a fail. Like I said, only one side will peak, the other side won't peak. So I'm going to call this hack a fail. I'm going to call this hack all these capacitors and diodes and that. I'm going to call transformer hack a success. I'm going to call the IF hack a fail. Alright, so I'm just going to give up on this thing. You can see I've tacked a 100 picofarad capacitor across the primary side of that IF transformer capacitor. That's when I couldn't get the peak. It kind of peaks now, not real well. Surprised that it peaks at all given the state that it's in. Also replaced this capacitor, this one right here, somewhat leaky, and with that in there I couldn't really get a peak at all. I changed it out. It somewhat peaks now. Obviously nothing in here is ideal, but so now got the volume all the way up. Get you close to the speaker here. Some of these are still pretty quiet. So that's one station. Pretty quiet. That's two stations, also pretty quiet. It's kind of one there. It's really quiet though, so we'll call that maybe 2.5. Another real quiet one, so maybe we'll call that 3 total so far. Got 2, stations that come in, and then, basically 2 half stations. Kind of one there over that noise. Hope these are coming in. There's one there. Somewhat, still pretty quiet, but got some noise on it though, unfortunately. This is still oscillating in this area for some reason. Right around 100 there. So there's a station there, but because it's oscillating over top of it, you can't really understand anything. So that comes in, somewhat acceptably. I think that would be, 4 total we counted so far? Not sure if we're counting all the real super quiet ones. Those other ones, that makes 5 so far? And that seems to be about it. Volume's up all the way. Yeah. That's the same one again. So we got about 5 total plus some ones you can barely even hear. So I think that's going to be... Now I'm going to finally give up on this. I really don't think there's anything else I can do without replacing that IF transformer. I just kind of just wanted to see if I could get that one side to peak, and now it kind of does. So now I'm pretty confident that's the best that we can get with that IF transformer. As I have played around with the RF trimmers on this radio, I'm not sure what the expected performance of this is, because it's a really weird design. Instead of having a regular dedicated IF tube, it kind of has an IF and detector in the same tube. It was a multi-section tube, as one pentode, and they went with an RF amp instead of an IF amp. So you can see here we have the RF amp there, then the mixer oscillator, then this is what would usually be an IF tube, but then instead of having like the double diode triode for the detector and audio tube, this IF tube basically feeds right into the audio output tube. So this is kind of like an IF and detector in the same tube. It's very, very strange design in my opinion. Definitely not your standard AA5 setup here. But like I said before, this is kind of what makes these radios more interesting, these 20s and early 30s radios, because not everyone followed a standard design like they did from like the mid 30s on. Mid 30s on, you've got your basic AA5 radio, mixer oscillator, IF, double diode triode, output tube, and possibly a rectifier tube or solid state rectifier. This does not follow that design, and not all radios of the early 30s did follow that design, which is what makes them somewhat more interesting. Also means, not necessarily that they're the best performers, but they're interesting at least. And this was a definitely interesting one. There's also something else I wanted to point out. The failure point, I think, started back here in the rectifier tube socket. If I can get in here with my tripod maybe. Right there. So you see that? So this right here looks like the socket is burned out in between these two pins. So there's one right there. So see how it's like, are we focusing on that? No, not really. Focus on that. There we go. So see how it's like burned out there, and you can see how there's like holes in the socket? Like not the tube pin holes, but like much larger holes. And it's all charcoaly carbon tracking there. So what I'm kind of wondering is, since these two pins are the either side of the transformer winding, I'm wondering if either that material failed, or maybe someone spilled some water in the tube socket and it started shorting between those two pins, because if you have like a 250 volt B plus, you would have to have like 500 volts between those two pins, or more than 500 because of the drop across the rectifier, because you're center tapped. So 250 on one side and 250 on the other side of the center tap makes 500 volts across those two pins total. So I'm wondering if maybe somebody spilled some water in there or something. Maybe the mouse peed in. I have no idea, but I'm wondering if something in there caused those to start shorting out. And once that happened and it started carbon tracking, started pulling a lot of current, that could be what cooked our secondary transformer winding. I don't think I've ever seen that before in one of these tube sockets. This type of material is used, from the early to mid 20s, all the way up, I think up into the 60s. They were using this I think this is like a phenolic material. It's kind of like, it's not really cardboard. It's almost like, some kind of like resin type board thing. I think that's called phenolic. They use this stuff in the base of IF transformers too. You can see here is more of it. Type of material. So, looking at it, it kind of looks like it's like a woven thing, but then it's like coated in resin. Like I said, I don't think I've really seen that much before. I haven't come across a lot of carbon tracking radios in general. But that's kind of what I'm wondering, and that's what happened. Somehow, either the material failed and became conductive instead of carbon tracking, or like somebody spilled something in there that caused it to short out, and then once current was flowing, it started carbon tracking, after that. But I'm thinking that's what happened and cooked our transformer primary. You can see, I was commenting earlier about how the copper was red, speculating whether that was because it was cooked or because of the lacquer. So, kind of see how the lacquer here is like a nice golden color, versus here, how it's all red. And you can see how all the bare parts are red like that. So, you can kind of see how it's a little bit golden on that winding right there. But I'm thinking that that cooked the insulation off and started shorting out, and that's what caused our issue. This got hot, it started cooking the insulation off, and then it started shorting, which would cause it to draw more current internal to the winding, which would just make it hotter and kind of like an avalanche effect. And I think when we measured this initially. I don't know if I showed it on camera, but the resistance was like 11 ohms or something. According to the schematic, it's supposed to be like 400 ohms. So, that right there was confirmation. Aside from the fact that it was just like burning itself up. But anyway, yeah, so it's daytime now. Played around with it a little bit more. I reconnected that RF choke. That coil right there, that was open. Reconnected that. Doesn't seem to really make any difference. Also clipped out that capacitor there that was in the audio output circuit. Don't really seem to make any like gain difference. Just raised the treble quite a bit without that in there. So now we're getting some stations. I'll sweep through here real quick. Volume's up. See the dial there. Stupid tripod is not gonna get a good view, but you can. I'll see what's going on. So I'll set down at the bottom. As it breaks into some oscillation, I'm not sure if that's because I clipped that capacitor out of the audio circuit, or if that's the RF doing that. Cessation there with quite a bit of noise too.
Let me ask you this: do you wear your seatbelt? Of course. Why?
Sounds quite loud.
Well, because it protects.
Turn the volume back up now that we're off that one. It's kind of one there.
Anything notable happened, and those hooks aren't as tight as they could be. But their hooks are here. Okay, he doesn't.
That's quite loud.
Hooks in his head. Wrap hair around. He's not bleeding from the head. No. A lot of these guys, when they get.
The magnesium factors in. I mean,
Give me some cash back. Give me your ballot here.
Sound down loud one again. So it gets a couple stations. Doesn't get my regular music station. I think there was another music station in here somewhere that it was getting. Let me see if I can find it.
Yeah, that's what he said when he's
It
reacting.
was down behind this one.
.com is just a few clicks away.
I want to pray for you.
it doesn't thin their blood at all. It just makes it so it won't clot.
Other big games coming up in the SEC.
I'll see if I can find that other music station. Alright, found it there. Hopefully you can hear that. It's not very loud, and it's not like high quality, but it's just barely there. So, it picks up a few stations. It's not like horrendous, but it's not great either, which is what we'd expect. So, yeah, I just want to do that one last station sweep. So, see, it picks up some stations.
Oh, we'll see.
So that's going to be it out for this one. Not really sure if I want to declare this radio working or not. Kind of works, but I'm sure that it would have much better performance in its original state. So I'm not sure if this is a success or not. Power transformer placement is a success, but overall, don't really want to consider this a success because even though it works, it's not great. This is not something I want to listen to, for any length of time. Though on some of the talk stations, maybe.
Judges interfering in the rules set by legislatures. The rules in most states are that the
So
ballot has to
those
be
wires off the speaker are rattling.
by the end of election day. But some states have a rule that says as long as it's posted.
I guess you could listen to that if you wanted to. It's not terrible.
Actually voted it.
Not that I listen to talk radio anyway, but
Some states will give you
so I don't know.
days after that.
Let's call it a half success.
Ballot to actually get
That's gonna be about it for this one. Hope you enjoyed this video, and thank you for watching.